Welcome to the 1958 Nobel Prize in Physics, which was awarded to three Russian physicists. Their names, and I'm absolutely going to pronounce these incorrectly, and I apologize for that, but I'm going to do my best. Pavel Alekseyevich Cherenkov, Mikhailovich Frank, and Yevgenyevich Tamm. I think I'm close. What they did was they discovered and offered an explanation for this thing called the Cherenkov effect. You're like, well, hey, what the heck is that? Well, it's Cherenkov radiation. It's kind of become known as the Cherenkov effect. Oh, there's more to it than that. But let's dive right in and take a look at it and understand why it was kind of interesting to be found when it was found the first time. Here we go. So the Cherenkov effect or Cherenkov emissions or radiation, whatever you want to call it, are this funny blue glow that you see coming out of some reactor labs. It's a little bit difficult to explain, but let me try to kind of take it this way. So what's happening is that the effect is produced when charged particles are moving faster than the speed of light in the medium they're in. Hold on a minute. That sounds like we just violated special relativity and that Einstein guy is going to be really mad at us, right? Well, let me explain. So this effect was first discovered in 1934 by Cherenkov. It wasn't explained until 1937, and that was done by Tamm and Frank. So the three shared the prize. So what happens is what relativity says, and that whole Einstein guy, I think, what that actually says is that nothing can move faster than the speed of light in vacuum. The speed of light in a medium, like water, isn't as fast as it is in vacuum. It's slowed down. So it is possible to get charged particles moving quicker than the light. And when you have that happen, you get this funny blue glow that occurs. It's used for several things scientifically because you can get it in natural cases. You can get it when some things come through the atmosphere because light is not vacuum. Light is another thing that slows light down a little bit. And if you get some charged particles moving faster than light, you get some of that type of radiation with cosmic rays. And what it does, that helps you figure out the energy and direction the cosmic rays are coming from. Are they coming from that way or that way or that way? And it's a pretty interesting way to do that. There's a few other scientific things that it's used for as far as measurements go, but it has this blue glow because what's happening is at higher energies, which are involved in the Cherenkov radiation, the photon will move at higher frequencies, which is shorter wavelengths, and that tends to be the blue side of the visible spectrum. Now, what this does is it gives you a chance to study things that are actually outpacing light in the medium they're in, and that's kind of an interesting thing to go look at because it might give you some insight into stuff in that medium or insight into those things that are moving and the way they move and how they move and how they behave. And all of those are very important things for physicists to go affect. And we have the Cherenkov effect for us as an opportunity to go do that. And it's pretty cool that light actually can be outpaced by something in a certain medium. Not in vacuum. Vacuum's a whole different thing. And light's the winner there, at least as far as we are aware. Now, is that going to hold true for all cases, or is it just the ones we know about? Well, so far, it's the ones we know about. And no physicist worth their salt will ever go, nope, that's it forever. Nothing's ever going to beat it, because every time you say something like that, something does. So, so far, relativity is holding strong. So that's really all there is to this one. I hope you've enjoyed it. I hope you enjoy the other videos on the playlist. Don't forget to click subscribe and like. And it's a pretty neat little effect. And if you want to Google it sometime, feel free. You'll get all kinds of funny blue glowy pictures that'll pop up. And it's pretty cool. I've seen it in person. And they tell you that you can swim in some of the reactor swimming pools in which you see this stuff, but I'm not diving in water that has that kind of radioactive material in it. There's not a chance. Not even I'm that crazy. Even though I understand it's not dangerous, I'm still not going in there. Everybody have a great day, and we will see you on the next video.